Okay, guys, this is a breadboard for basic electronic labs. And keep in mind, we provide an introduction to solid state devices because some of them behave as solid state switches. Okay, so a breadboard is behaving like a matrix. So we have column identified by numbers and row identified by letter. For example, A1, B1, C1, D1, E1 is a column number 1. And all of these are electrically connected. But A1 is not connected with A2. So column 2 is not connected with column 1, and so on. And we have a divider here. This divider is used to separate the two sections of the breadboard. The bottom one, we have a matrix as well. We have F1, G1, H1, I1, and J1. This is the column 1. But this column, all the cells on this column are interconnected electrically. F1 is connected with G1. G1 is connected electrically with H1 and so on. But these are not connected with the F2 or G2 or H2 and so on. And at the top, we have a whole line covering from one end to the other end. And if you apply in any of these holes, okay, 5 volts DC, the whole row will have 5 volts DC. And at the top we have the blue one, minus, the same. If you apply and connect any of these holes, just one hole, to the negative, all the row will have the same voltage, okay? And keep in mind, on DC, the black one is not the hot line, is equivalent to the negative or ground, and the positive, the red one is the positive. If I want to use 3 volts DC, the positive will be here and the negative will be connected on this. And at the bottom, we have the same rows. So the red one, from one end to the other end, is electrical connected. If I apply 3 volts positive on the red one, all the holes in this row, the red one, will have 3 volts DC available. And the blue one is for the negative, okay? So the same, all the holes in the same row are electrically connected.